Now at this point, I trust that you're comfortable solving a quadratic equation that contains an x squared and an x term by using the method of completing the square. Now what we're going to do next is to apply that method to the general quadratic equation, ax squared plus bx plus c equals 0. And that will then lead us to a very important and useful formula called the quadratic formula. So let's begin. You'll know that the first thing we need to do is to take the constant term to the other side. So we'll have our first step here, ax squared plus bx is equal to negative c, because we want to isolate the x squared in the x term. Now next what we'll do is to divide each term by a, because we would like the coefficient of the squared term to be 1 before we complete the square. So we'll have the next x squared plus b over ax is equal to negative c over a. Now we next need to decide what to add to complete the square. So we're going to take 1/2 the coefficient of the x term, which is b over a, which will give us then b over 2a. And what we do next then is to square that. So we have then b over 2a quantity squared, which will then give us b squared over 4a squared. So we need to add that constant to both sides of the equation. So we'll then have next x squared plus b over a times x plus b squared over 4a squared. Then adding that to the right hand side, we have negative c over a plus b squared over 4a squared. Now we can easily factor the left hand side, but on the right hand side we need to get a common denominator to combine those two fractions together. So we'll do that next. Now you can see that the lowest common denominator of the two fractions on the right hand side will be 4a squared, which means we need to multiply the numerator and denominator of this first fraction by 4a to change it into a form that will give us that lowest common denominator. And so what I'm going to do next is to factor the left hand side. It'd be then x plus b over 2a quantity squared. And on the right hand side we have negative 4ac, then plus b squared all over 4a squared. And what I'm going to do next, before we take the square root of both sides, we're going to reorder the terms in the numerator of the fraction on the right hand side. So I'm going to write this as b squared minus 4ac then, all over 4a squared. At this point you know we need to take the square root of both sides, so we'll have the next plus b over 2a is equal to, and don't forget we want both the positive and negative square root here, so we put the double sign in front. So we then have b squared minus 4ac all over 4a squared. And we can rewrite that right hand side using the quotient property. So we'll then have positive and negative, the square root of b squared minus 4ac all over the square root of 4a squared. So we then have x plus b over 2a is equal to positive and negative the square root of b squared minus 4ac all over 2a. So we'll next then, to end up, we'll subtract the b over 2a that you see on the left-hand side there from both sides to isolate the x. So now if we add negative b over 2a to both sides, we'll isolate the x term. So we'll have the x is equal to, I'm going to put the negative b over 2a in front here of the radical on the right-hand side. So we have negative b over 2a and plus or minus the square root of b squared minus 4ac all over 2a. And the good news here is that those two fractions have the same denominator, so we can combine them into one fraction. So we have the negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Now this is a very, very important formula that you want to be sure that you memorize. And it's referred to as the quadratic formula. So let me write that here, quadratic formula. And what this will allow us to do is to solve any quadratic equation by simply substituting in the coefficients of the terms in the equations a, b, and c. So what we'll do next is to consider an example where we use the quadratic formula.